simulate was for the primary outcome, we set up this model. For the secondary outcome, we have this model. You can see that those are all logistic regression models. But our objective here is to estimate this theta 1 here, right? So our parameter here, remember, this is the parameter we want to estimate. I said 0.5. This parameter are the association for the primary outcome, which is important, but not the concentration of this talk here. Okay. So now the next things we do, if we run for this kind of case control study, if I run a logistic regression model based on this, or another logistic regression based on Y, given D and GE, what kind of bias we would expect. Okay, this is the simulation results. Here, let me explain a little bit here. This up graph is the bias in estimating the theta 1. Remember, theta 1 is the association parameter we want to estimate. It's actually the log odds ratio, okay, between the genetic marker and the secondary tree. Okay, so if we perform a marginal analysis, then here, when this axis is actually the prevalence rate, when the prevalence rate is very small, let's say between 0 and 20%, then you are going to see a relatively big bias. But when this prevalence rate is relatively large, then this bias is not that apparent. For conditional analysis, remember the conditional analysis is conditioned on the primary tree. It's a relatively different picture. At the very beginning, the bias is virtually none. This corresponding to, usually in statistics we call you have a spice disease or rare disease case. As the prevalence rate increases, then you see that the bias increase very rapidly. Okay, and then up to a certain point, it stabilizes. Okay, so you may think what kind of impact on the rare case control study. We know rare case control study, usually the baseline prevalence rate is relatively small, maybe 0 to 15%. You can see that in this case, bias is relatively large in this case. So it makes sense that we should correct this kind of bias. Okay. So the case control study usually fall in between this one. Of course, in this conditional analysis, if the rate is very small at the very beginning, you don't see a big bias. But this bias increases very rapidly. So even for a small prevalence rate increase, the bias can increase substantially. Okay. So this is basically the summary of the observation, the results we observed from this simulation study. Okay, so let's give you a brief summaries on the approach we use for this kind of analysis, the existing approach here. The simple approach is the best approach is this marginal and conditional analysis. Lots of people nowadays actually they do I talked to some statistics genetics. They say people doing genetic usually do this two kinds of analysis in practice. Okay. So of course, in the literature, we have some other choices other than this marginal and conditional analysis. One of this method is based on missing data approach. This approach basically viewed this case control study as a special case of two-stage design. In two-stage design, the first stage you sample subjects and measure the primary outcome and a bunch of covariates. Then in the second stage, you measure, you sample a subset from that big cohort. And the second stage sample is usually treated as case control study sample. But this treatment, if we can use this kind of treatment, then there are a bunch of methods that we use to handle missing data can be applied to this particular problem. Okay. Those methods, including the pseudo-likelihood approach, this weighted likelihood approach, and a somewhat fancy approach called doubly robust estimating approach. Those are all missing data approach. But there's one requirement in order to using this missing data approach. That is, you have to have additional data to use. This additional data is that you have to have a very well-defined cohort and where you draw your case control sample. And this, you have to have information on those cohort, like size of the cohort, like the relevant variable you measure, the number of cases, number of you observed within that cohort. But in case control study, usually we do not have this kind of information. If you don't have this kind of information, then this method cannot be used. Okay. So another approach is basically just treat this as a by-sampling approach. Okay. Some people sometimes do case-only analysis. Basically, they say if you if you look at the controls, it basically means the outcome, the secondary outcome, and the primary outcome is somewhat unrelated, because in the control, the primary outcome is all zeros. So you think in the population there is many controls. So basically, this basically assumes that the disease you are on the study or the treated on the study is very rare. Okay. In our situation, it basically says the higher density limit is relatively rare in the population, but it's not true, because we sampled from 90% of those subjects. That's not quite rare. The other is to use retrospective likelihood. This approach currently the most statistically most sounding approach. Okay. One approach is to use retrospective likelihood with supplement of the prevalence rate for the primary phenotype in the population. The second one is that if we don't have this supplement rate information, then the first one is not, the second one is actually a waste. If we don't, what we do, we can do the retrospective likelihood approach. Okay. But those two approaches has a particular problem here. If you use this approach, you need to estimate the theta zero. Remember, in a second trait model, actually let me go back to. If you use that approach, it requires us to estimate this prime. next one. Okay, here. It requires us to estimate this parameter. We know in logistic regression model, usually this parameter is not identifiable. But if you use a Lin-Zen's table method, you end up need to estimate this one from the data. We can show that it is identifiable from the data, but it is very extreme difficult to estimate because the data has virtually little or no information on this one. So that makes the computation problem very difficult to do. Okay? If we supplement this population prevalence rate, and then use a constraint maximum likelihood approach, then I will show you that in lots of situations, this cannot be done appropriately because of the case control sampling design. Usually, it's not a population base. It is based on a subpopulation of the general population. So what we propose to do here, so our proposal here is to do a bias correction. Basically, based on two simple analyses. Remember, if you do the conditional analysis, then we can supplement another conditional analysis, and then we can combine those results together to get a bias correction. If you do marginal analysis, we can also supplement another conditional analysis, and then combine the results together to get correction. Okay? So this correction approach does not need us to know the exact prevalence rate for the primary outcome. And it is very fast if you want to screen a large number of markers and also evaluate the sensitivity of the estimate to the prevalence rate. Okay? So those two pairs are important in generalized association studies. So if the first things we did was correcting to the marginal analysis, what we do is like this. So the first things you do is to run a regression analysis to get a to run the second model. The first things you do is to run